In today's video, I'd like to talk about cleaning things. So there's a huge selection of solvents available, but how do you actually choose one? So today I'd like to give away some tips and tricks and also explain some of the science behind these cleaners. First of all, don't forget that water itself is actually a really great cleaning solvent, and for some types of dirt, it's actually the best possible solvent. And so to show this, I've got a microscope slide with some salt that I've dried on, just plain old sodium chloride, and I'm going to start off by drizzling some anhydrous alcohol on this. So if you buy this from an electronics store, you can see it's 99% anhydrous alcohol, meaning that there's very little water in this. It's almost entirely pure isopropyl alcohol. And so I've got some in a wash bottle here, and we're just going to spray this over the salt and see what happens. As you can see, not very much. And the reason is that the alcohol is not particularly polar and it doesn't dissolve the salt particularly well. So let's try this again with just plain old distilled water. So this time, the water was very effective in dissolving the salt, and as the water is sprayed across the slide, it carries away the dissolved salt and effectively cleans the surface. And so this holds true for other substances as well. This slide has some dried on sugar, which doesn't crystallize quite like the salt does, but we'll try the same thing, and by putting isopropyl alcohol in there, anhydrous, it kind of makes the sugar harder to see, but trust me, it's still there unaffected. Let's try the same thing with just distilled water. So the first rule for choosing a cleaning solvent is like dissolves like. And so if the thing that you want to dissolve is polar, like salt or sugar, then you want to use a polar solvent, like water, to dissolve them. And using something that's not correct, like isopropyl alcohol, actually won't have much effect at all. It won't help your cleaning job in the slightest. And it's partially for this reason that most of the alcohol sold at supermarkets and drugstores is actually 70%. The additional 30% of water in there is actually what allows you to clean away a lot of the dirt. So if you're going to clean like dried on blood or a grass stain or something like that, the 70% isopropanol is actually more effective because it has the water already in there. The reason that you might want anhydrous alcohol is if the thing you're cleaning is sensitive to water, like an electronic circuit, then you'll want this just to avoid using the water altogether. So how do you know if the thing you want to clean is polar or not? Well, as it turns out, most of the dirt that we actually have trouble cleaning in the world turns out to be non-polar. If it were polar, then we could just use plain old water and be done with it. But the entire cleaning industry is pretty much dedicated to cleaning difficult non-polar substances. So for example, I have this permanent pen mark on the microscope slide, and if we just try to clean it with plain old water, of course nothing happens, and it's permanent pens, not supposed to come off in water. So we'll sort of turn our efforts up a little bit here, and we'll go to the isopropanol and see how this does. It's starting to dissolve it. As you can see, it's removed some of the pen, so some of the chemical compounds in the permanent pen mark have dissolved in the alcohol, but it hasn't really cleaned the slide, it hasn't gotten everything. So if we up our efforts again and switch over to acetone, acetone is a partially nonpolar and partially polar solvent. Now let's see how well this does. The acetone has no trouble at all, just completely removing the permanent pen mark. So let's talk a little bit more about how to choose the solvents and the differences between them. There are a few numerical scales that have been developed to describe how effective a solvent is at doing its job. And so I'll put links in the description, but one of them is the Cari butanol and another one is the Hildebrand. And they aren't used all that commonly because each cleaning job is so unique, it's kind of hard to use a single number to describe how good a solvent is. So for example, if you were cleaning wax off of a circuit board, you might choose one solvent that has a lower, KB number than another one, but it's really well suited to that task for a number of other reasons. So I'm not going to go into detail about the exact, ratings for each of these, but just keep in mind that some solvents are quite a bit more effective than others for a specific job. So as we saw with the marker, isopropanol only sort of half removed the marker, whereas acetone, had no trouble with it at all. And going up from acetone, the solvents get quite a bit more effective until we're into chlorinated hydrocarbons like this that you typically can't buy at the hardware store because they're just a little too good. Keep in mind that no matter how good the solvent is, we still have to remove the dirt. So here's a microscope slide with a little bit of grease on it, and if we put a drop of solvent on there, imagine that this is, the best solvent in the world and it instantly dissolves all the grease. If we don't do anything and we just let the droplet sit there, what's happening is we now have a mix of all the dirt plus the solvent, and if we wait long enough, all the solvent is going to evaporate away, and 100% of the dirt that we started with is still going to be there. So an important part of cleaning with a solvent is having a flow or using some mechanical means to remove the dirt. So let's take a look at that. In the simplest case, we could just use a paper towel. A rag or a paper cloth is fine, and what happens is the solvent will allow the grease to be dissolved, and then it comes off in the cloth, and the space between the fibers in the cloth are what catch the dirt and allow it to be removed. However, there's a slight problem with this. Even if your cloth is really absorbent and is able to pull as much of the grease as you can see off of the surface, there's still a vanishingly thin layer of grease left on there. So let me show you a test that will allow you to see if there's a thin layer of grease left. Here's the slide that looks clean, but if we just take a regular old jet of distilled water and spray it on the apparently clean section, we can see the water actually pulls away from the glass. Let me switch over to a piece of stainless steel so that it's easier to see. It looks very clean, but if we try the water test on it, we can see that the water just beads up. And what should be happening if the surface was really, really clean was that the water would form a nice sheet across it. The water would sheet off. Having a surface that passes the water break test, in other words, allows the water to sheet off and not bead up, is important if you want to paint or put an adhesive on this surface. If your last project that involved paint didn't work out so well, it's possible because that the surface wasn't prepped properly. And it's a very sensitive test, so if you use one of the methods that I'm going to show you in this video to clean this surface such that it passes the water break test, and then you just leave this sitting around in the air for a day or two, just the random amount of oil and dirt floating around in the air will actually cause it to fail the test after just sitting around for a day or two. So it is a very dirty world, and it takes a lot of effort to clean things and keep them clean. So I mentioned that the main problem with using a paper towel to clean something off is that it just pushes the solvent and the dirt around, and there isn't really any removal of the dirt. Even if you use pure solvent and you change paper towels often, you're still going to be leaving a very thin film of grease on the surface. And this is partially because the solvents that you buy at the hardware store aren't pure anyway. And if you want to have a really good painting job or a really good adhesive job, that last layer of grease has to go. So one of the sneaky ways that we can get around this problem is to boil the solvent in a container and then let the vapor drift up. And I'm going to just dip the slide into the vapor that's in this beaker. And what will happen is the solvent vapor will condense onto the slide, and then the grease will dissolve, or the dirt in this case, the permanent marker, will dissolve and drip off down into the bottom of the beaker. So let's see how that works. It's extremely effective, and what's cool about it is that the boiling vapor, the boiling solvent, just condenses on the slide, and the dirt stays down in the liquid there because it doesn't boil. It's much less volatile. And if with the right selection of solvents and everything, the slide even dries itself. So the thing is really, really effective. And what I'm showing here is actually trichloroethylene, which is how they cleaned circuit boards and lots of other things in the 80s before we found out that chlorinated hydrocarbons weren't so good. But you just saw how amazingly effective this is. So let's try this on a more demanding application. Here's a slide with some authentic road grease from the bottom of my car smeared on there. So we'll put this into the vapor stream and see what happens. Very effective. And so most of the grease has just dripped off. And you can see there's a few spots where it's still a little stuck. That was probably non-polar dirt, like literal dirt from the earth, earth smeared on there that's just holding on by a very weak sort of physical connection. You can also see that the effectiveness of the vapor cleaning goes down the longer that the slide is in there. And the reason is that when the slide is cold, it condenses a lot of vapor onto the slide, and that's what causes the washing action. Whereas after it's been in the bath for a while, it's warmed up. So we'll take it out and just kind of let it cool to air temperature and give it another pass and see how that goes. What's interesting is the dirt that's left on the slide is completely dry. There's not a trace of grease left in there because the solvent cleaning was so effective. And so if we just use one of these air dusters, it actually just blows away the remaining dirt entirely, and there's like a trace of something left. So if you were designing an industrial cleaning process for this, maybe a trip through the vapor cleaning and then an air blast and then a trip through there again would be sufficient. As you can see, all the dirt is left in the bottom of the beaker, and if you watch carefully, you might be able to see the vapor coming out. As I mentioned, the trick with this is that as it's boiling, it's only the vapor that comes up and the dirt stays down there. But the problem is that I just released a whole bunch of volatile organic compounds into the atmosphere, chlorinated volatile organic compounds on top of all that. And, this process isn't really used industrially so much because the escaping solvents are bad. And then even if you capture the solvents, you have to do something with the dirty, like the really sludge at the bottom that's, saturated with the solvents. So let's look at another alternative for getting that last film of oil off of something if you need to critically clean something that doesn't involve solvent cleaning. Okay, so here we are with a piece of metal that looks clean but is failing the water test. And just to show that this is not going to work with the solvent approach, we're going to take fresh isopropanol right out of the bottle, fresh Kim wipe right out of the box, and try to clean it. And so you'd think, well, we're doing a really good job cleaning it now. It was a completely new Kim wipe and new solvent, and we'll try the water break test. You can see the alcohol is evaporating away. It's better. It looks slightly better than it was, but you can still see the water is beating up. So if we wanted to paint this, I'd be concerned that the paint would flake off in short order because you're just not going to get a good bond there because of that last remaining film of oil. And we also determined we can't use the solvent cleaning option because it's environmentally a problem. But luckily, there is another alternative, and that's to use a substance that chemically converts the dirt that's on the surface. So instead of using a solvent that just sort of pushes the dirt away or dissolves it and then washes it away, if we use something like this that contains bleach, the bleach will actually oxidize those hydrocarbons, that film of oil that's on the surface, and convert it into a different substance. So instead of just pushing the dirt away, we're actually actively changing it. So let's try a little bit of this stuff. And we're just going to use plain old water. And I'll try to do half of it so that we can see the water break test is different on the other side. And then we should be able to just rinse with plain old water. And as you can see, it's already significantly different. So if I turn it this way so that this was the half we treated, and the other half is untreated, you can see that side is just beating up just like it was when we started. This side is now passing the water break test quite well. And this is what you want to see before painting something, because then you'll know that you've got that last bit of film off. So the takeaway point is that just because a solvent is extremely aggressive and potentially banned for being a health problem and all that, doesn't actually necessarily make it more suited to your cleaning task. If you're prepping a surface for paint, and your surface can tolerate being wet, using a cleaner like this is actually really good. It's mildly abrasive, it includes an oxidizer and basically a soap to get the part as clean as possible. I learned this trick from Dan Gilbart, and I'll put a link in the description, who has a whole bunch of really great videos that are worth watching. But let's say your part can't tolerate being wet, and you can't use solvents like this because they're falling out of favor, and you still want to clean your hydrocarbon gunk off the surface. There are more alternatives, and one of them that's pretty hot these days is using liquid or supercritical CO2. I have a number of videos about supercritical CO2, and this is the chamber that I've shown in previous videos. Even though CO2 is a gas and you're probably not thinking of it as a cleaning solvent, if you compress CO2 and make it into a liquid and then heat it up to make it into a supercritical substance, it's actually a really good solvent. It's so good that dry cleaners use it, again, because it's not wet, and so you can't get the garment wet. But if you put the shirt into a chamber with liquid CO2 and make it go supercritical, you can actually clean oil stains out with that. And everyone likes CO2 because it's a totally inert solvent. You can just release it to the atmosphere and it's totally fine. It's such a good solvent that my chamber, which is built out of acrylic, is actually slowly dissolved by the supercritical CO2 that it's containing. And so I would not use this chamber to hold the substance for a very long time. I've only let it sit in there for a couple days at most, and it'll take a long time for the supercritical CO2 to penetrate through this thickness of plastic. But what's interesting is that you can see it's sort of got the case of the bends here. Let me show you what it looks like. Here's what one of the acrylic windows looks like after it's been at pressure for a while and then decompresses. As you can see, it's got one heck of a case of the bends, and so what's happened is the liquid CO2 has penetrated into the plastic, and then over the course of an hour or two, the CO2 decompressed, and this was a very soft material because the solvent was working on it. But there's actually another cool invention that lets you use the cleaning power of CO2 outside of a chamber. There's at least one company that makes a CO2 cleaning gun, and it basically works by having a large tank of liquid CO2 and a nozzle, and the idea is that when you open the valve, you get a stream of CO2 liquid that's coming up the pipe, and when it hits the atmospheric pressure air, it freezes into CO2, dry ice, and then the dry ice snow basically hits the surface that you want to clean, and as it strikes the surface, it converts momentarily back to a liquid, and solvent cleans the surface, and then continues off into a gas and blows away. So the idea is that you're able to sort of blow the dirt off of the surface in one fell swoop using the cleaning power of liquid CO2. So I tried to get this to work. Let's zoom in on this slide where I've got a little bit of grease on it, and I'm going to use this nozzle here and just see if we can clean it this way. As you can see, I'm not really having much luck with it. I'll put a link in the description, and I've seen their product actually work quite well, so don't take my word that it's no good. But the concept is really cool, and it actually is used for cleaning glass and optics because it actually is very gentle on the surface and leaves no trace since the CO2 just completely evaporates right away. This is actually water vapor just because it's so cold. I think their gun uses the chips of CO2 in a room temperature airstream to try to prevent the condensation problem. I thought we'd end with a less common but really interesting cleaning problem. This is a bowl from my kitchen, and you might have some in your house that look like this too. Do you see the sort of the scratches at the bottom? Those are actually not scratches in the porcelain. It's actually a metal deposit left from metal utensils scratching it. And so you can see that if we scratch the bowl, what's happening is the porcelain of the bowl is much harder than the metal of the fork, and it's leaving some of the metal on the surface of the bowl. And depending what kind of metal your utensils are made out of, this might be not so hard to clean off, or it might be almost impossible. So you can get in there with, Comet is a good choice because it's slightly abrasive, and you might be able to, with enough rubbing, get that off. However, there are some metals that will leave a mark, and you will not be able to get them off with any household cleaners. So I've got this titanium bar here, and we'll leave a nice big scrape with the titanium, and believe me, there's no amount of scrubbing with Comet that's going to get that off. And the reason is that the titanium deposits a little bit of metal on here because the porcelain is harder than the titanium even. And then after a few minutes, the titanium forms a very tough oxide skin on this metal, which is why this is so corrosion resistant. It forms a protective oxide layer. And the titanium oxide is just as hard as the porcelain. So if we were to go in here with an abrasive, we would be rubbing the bowl away just as effectively as we were rubbing this oxide protected band of titanium. So it's really an effective way to mark glass and porcelain permanently. And in fact, they even sell titanium pens for artists that work with glass, and they can sign their name with the titanium pen, and it's practically indelible. However, let me show you a secret chemical blend that will get this off very effectively. Okay, so the magic cleaning solution that will instantly take off that mark, I'm going to mix up in this little bottle, and it is 10 parts by volume, just plain water. And the exact quantities are actually not so critical for this recipe. 1 part hydrogen peroxide, and you cannot use bog standard like 2 or 3% hydrogen peroxide. You have to use something like 18% is commonly available on eBay. And then the really secret ingredient, fairly concentrated hydrofluoric acid. This is about 50% or 48%, I think is the theoretical maximum. And it'll be 1 part by volume of that. And I know the safety guys are already jumping out of their seats. Yeah, it's pretty bad stuff, just don't let it get on your skin. Unlike chemicals that are pyrophoric or explosive or react with everything, I actually don't think this is so bad, but definitely don't let this get on your skin. Using it is pretty straightforward. You just want to get a little bit onto a rag. Let me zoom in so you can see this. Takes it off lickety-split. The name given to this substance is called piranha, and it works by a very clever technique. It relies on both the hydrogen peroxide and the hydrofluoric acid. Since I mentioned the titanium forms this protective oxide layer, what happens is the hydrofluoric acid etches away that titanium dioxide and exposes fresh metal, and then the hydrogen peroxide oxidizes that exposed titanium surface and creates more oxide, and then the hydrofluoric etches that away. So it's kind of this combination, symbiotic reaction that is able to clean it off so effectively. So it does etch glass very slowly, but the dilution is low enough where if you just rub it on there for a while, you notice there's really no surface problem. It's not like there's a trench or anything etched into it. Okay, hope you found that interesting. I'll probably do some more videos on specific cleaning things, so let me know if you have any questions. See you next time. Bye.
Dust is going to sit on a number of the surfaces. The quickest way to get rid of the dust is to use cobweb brush. Okay, so let's say have a look at the air conditioner up there. So our cobweb brush is extendable. Yeah, so everybody knows how to extend a cobweb brush. Yep, right there. Wrap it around like that. So if you have a look here, you can quite easily get up the top there, and because of the bristles, it can actually flip the dust off. So before I've started cleaning anything inside of a room, so we're talking about pre-sale clean, okay? So I want to use my cobweb brush to flick over the dust up there. Now, if there's paintings, should I be touching the paintings?
No.
Why not? What do you think?
Upper side. It might be upper side.
We can clean with cloth. We can clean with cloth. Yeah. Okay. What I want to point out with paintings, how much is that worth?
A lot.
That's right. Okay. So we don't want to touch people's personal items. Okay. If somebody has come to us and said, "Can you dust over the top of that?" then you have two people, one holding it, the other one dusting over the top of it. But generally, you wouldn't leave it. Now, if it's an empty house where there's nothing inside the house, then what would we do with that if it's on the wall?
Sorry, you need to call the office and then phone them.
Okay, so calling the office is a good thing. Yeah, because do we know whether that's rubbish or not?
Yeah.
We don't do it. So throwing away somebody's personal item, that might be a lot of value through to somebody. So yeah, you said we would give a call through to the office. So then I use my cobweb brush and I flick over the skirting boards. So it didn't take a huge amount of time to be able to get the dust from there to there, does it? So I can use this to go over the top of the ceiling,
Yes.
in and around the light fittings, etc. Now, if that light fitting had like a light cover on it, what would I do?
We have to take out the cover and then...
And clean it out?
Yep.
Yep, that's really good. So if I'm taking that light cover off, now we work with minimum 2 people when we go do a job, okay? So if I have a ladder, so we're going to pretend that that's a light fitting that I'm going to take off, okay? We carry a 3-step ladder, okay? Why do you think it's only 3 steps? Why do you think there is only 3 steps on that ladder?
Because that's a maximum height on which you can work.
That's right, height. What's the highest and high that you can go? 2 metres. Okay, so we want to make sure that you're protected each time you actually get up there. Now, should you go to the 3rd rung? Yeah, no, anybody. Should you stand here? Should you go any further than here?
Not really.
No, because it's not very safe then, is it? You're going to be overbalanced. So if somebody is taller amongst you, get that person who's a little bit taller. So if I'm reaching up there, taking off that light cover, it's better that I've got the person here to hand it to, wipe it out, and then pop it back up there. Works a little bit quicker, doesn't it? Yep. Same as the actual filters and everything you come from the air conditioners. Take it down, take out the filters. Sometimes the filters you can use a dustpan and brush to give it a quick dust. Other times you might have to pop that in water. Cool. Okay. Down the bottom of our ladder, can you see what's down the bottom of our ladder? See how it's got the stops? Okay, that's going to prevent you from falling. We carry this brand of ladder, and that's what we provide to all of you for a reason. A, because it fits in the back of your car perfect, but the other reason is that because of the safety component of this particular ladder. Okay? Right, so now we're back inside of a property that's for sale. So we discussed before that we're going to get rid of the dust, we're going to do the windows, marks on the walls. Now in the kitchen, come over here into the kitchen. Just turn the light on. So again, somebody's living in this home and we want to make it presentable. So in the kitchen, we're certainly going to clean the kitchen bench, aren't we? We're going to clean the sink. Yep. We're going to clean the tap handles in and around the base of the tap. Now, sometimes a lot of our cleaners forget to actually clean the base in and around the actual plug itself. Sometimes we've got other types of plugs, but this type of plug, but actually inside of the hole. Now what's the best thing to clean inside of here? Steel wool, I suppose. Yep, steel wool. Yep, that's really good. What product is the best that we can use to clean inside of here? Amaze? Yep, cool. Do you reckon you could go find that amaze? Yep. Okay. Now, while she's grabbing that amaze, if you have a look over here, now if somebody's selling their house, we're going to have a look up and under here to the range of filters. We would be cleaning the splashback tiles over here. Okay. We would be taking apart the stovetop, taking off the knobs, pulling all this apart. Now, we're going to clean the front of the oven. Now, would we clean inside the oven?
Yes.
Do you know whether you're supposed to clean inside of the oven? We're cleaning the external of everything. Does the client want the oven cleaned? Good. Excellent. Really, really good answer. Because anything you're not sure of, we need you to give us a call at the office, send a text message through, and what is the best thing to let us know what condition it is to take the photo. Okay? So we would assume at this stage, well, the office has said yes, that the client wants to have that done. What else here in this kitchen would need to be done? So we're doing the bench top, the splashback, on top of here, underneath here, the filters, the stove top. We're going to do the front of the oven. What else needs doing? Covered sinks, handles. Covered the handles, which is really good. I'm impressed you picked that up. Yeah. Okay, so with the handles themselves, what I tend to find a lot of cleaners miss is actually cleaning in and underneath. Okay, we'll clean in and around the outside, but we forget to clean the underneath. Now, if I'm coming to have a look at this house that I want to buy, I'm probably likely to actually open up the cupboard to have a look to see how much space is there, aren't I? Okay, so if I've opened up that cupboard, say that there's nothing here. Okay, what difference is there? What else do we have to clean?
You have to keep the top of the knobs, the
Top
hinge.
Yep, for the hinges?
Yeah, the hinges.
Yep, because the hinges a lot of people actually forget to give a clean out. Underneath the
Underneath.
shelf, on top,
Yep.
on the sides, and around the back. Yep, good, excellent. Alright, now if you want to come around here for a second. Bring around here. Inside of drawers. Now we're just going to take these items down. Now, I just want yeah, so inside of a drawer, we're going to be cleaning along the top here, along the side, along here, in and around here, along the face, in and around the handle. Now, if I clean this, I want you to, can you grab me 2 cloths, please? Thank you. The darker blue and the pink would be perfect. Now, if I'm starting to clean, what should I have on my hands?
Gloves.
Okay, so what's the importance of actually having the glove? Why am I putting gloves on? Protect the skin. Protect your skin, okay. Do I know what germs are inside this property?
Yes.
I don't, do I? Okay. But not only that, any damage. Sometimes when we're cleaning, it's very easy to cut our fingers, and you don't really want any of the dirt or anything entering into your fingers. Now, when we're cleaning a smooth surface, okay, this is smooth, where's my 3-step process? I'm going to wash, I'm going to dry, and then I'm going to polish. Okay, so what we're going to do is wet one of these cloths, nice and simple. Now, I don't need a lot of water in this cloth, okay? Not at all. The more water that I have on the surface, that equals the more water that I'm going to have to actually take off, doesn't it? Does that make sense? Cool. Now, one of the easier ways to actually get rid of all of the crumbs, etc., inside of the cupboard drawer is what? To vacuum first. This is good. You listen to the other day on the test. Okay, but if I finish cleaning this drawer, okay, and I throw the drawer back in, what do you think is going to happen? What it's going to do, it's going to dislodge any of the dust or any of the crumbs that are in the corner, okay? So if you want to do it this way, all that I'm doing there with my hand, so I grab that and then I flick it outside, okay? So in this instance, we'll probably not try to put much on the floor. So I'm popping my fingers just into like a thing like such, so that way I can get right into the corners, wiping around like such. Now I've got 2 cloths in my hand, okay? The other one I'm going to dry with. Now if there is lots of marks inside of there, how am I going to get those marks off? I've used my wet cloth, my dry cloth, but there's marks in there. How am I going to get them off?
Amaze.
The amaze? Yeah, okay. And what is the best thing to put the amaze on? Sponge. Okay. So why do we use a sponge?
To prevent rashes, or what is that called? The marks and all?
Yeah, okay. We use a sponge. If you can grab a sponge right there for me. And the amaze is, yeah, here it is. Here it is. Okay. I want to show you something really quick. So with the sponge, we have to wet the sponge first, okay? So with the amaze, the wetter that I've got the sponge, the better it is, okay? If I've actually used the cloth to use the amaze gets wasted. Does that make sense? Okay. Whereas a sponge, I can smear it a little bit further. Whereas with the cloth, it gets absorbed very quickly, and also it just gets wasted. So if I wanted to get rid of a mark, try on the soft side of the sponge first, then flip it over, and then use it on the other side. Okay. And then I'm going to dry it off. I'm going to grab my cloth. Now that's very clean inside there. Now just watch what happens. Now give it a little bit of a bump. Can you see all of that stuff? Now, that really needs to be what you focus on. You think that you've finished that, and then you've closed that door, because you haven't opened it back up again, that other stuff has come dislodged, okay? So, just watch what it is that you're doing in your final result of what you're doing. Okay, so along the top, when I'm using the microfiber, the best thing about using this product is that when I'm moving it along the surface, when there's some dirt or something sticky there, it actually stops, it pulls. Does that make sense? So, as I'm pushing, you'll feel there's like a bit of resistance that's actually there, and now it's nice and smooth, so now I know that I can actually dry it. Does that make sense? So when I'm cleaning inside of this drawer, it's not going to take a massive amount of time for me to actually clean it, is it? How long do you reckon it would take me to clean inside all the drawers, the cupboards, the dishwasher, etc.? Not the oven, the stove, and the range. Just an hour. About an hour? Yeah, which is a really good time. If you get to the property and it's really super greasy, okay, well, what is the first thing that you really should be doing?
Photograph.
Photograph? Brilliant. Now, are you going to need more time, do you think? Yes. Okay. So you should be ringing the office with that photograph and saying, hey, this property's a little bit greasier, it's going to take me a little bit more time to do. Okay? Cool. Now, I don't want your phone call at the end of the job and saying to me, oh, it's taking me an extra 3 hours. Yeah? It's a little bit, that's right, it's a little bit late at that stage, isn't it? Yeah. Yep. Cool. Alright. So, dishwasher. So what are we going to clean inside the dishwasher? Now it is. So, we're going to definitely clean along the face. Yep. From inside, like the ground area. Yep. Now this is a smooth surface, isn't it? Okay. So all I'm going to do can you see how just with the cloth, I haven't used any chemicals there, have I? Nothing at all, just the wet cloth. So why would I go and then use a chemical to spray on there first?
Yes, absolutely.
I don't need to, do I? Yeah? Cool. So if you get like a little bit of tough stuff, generally you can use your hand. Otherwise, you can use your sponge and be able to get it off with your mace. Cool. Now, by using my other clothing behind me, I've then dried the outside of the surface. Now, because this is a smooth surface, I really should use the polished cloth once I'm done, once it's fully dried. I'm not going to do it now because once I clean the outside, all the cupboards, etc., some of the water may fall down, okay? So I will come back and overdo that when I'm at the last of the day. So, dishwasher. We definitely want to clean along the top here, okay? We definitely want to clean in and around here. Down the sides, okay? So anything to do with the door itself. Now, if you got to a job and the inside of the dishwasher was really dirty, you would certainly give that a clean. There's some filters in there. Take them out, give them a bit of a rinse out, and then pop them back. But generally, you're only focusing on the outside surrounds and the actual door, etc., and the seals. Okay? So cleaning, fully clean of scrub on the inside of the dishwasher, it's not really necessary. Okay? Filters, yeah, give them out, give them a clean. Alright, so cupboards, very similar to the door, isn't it? So I'm going to clean along the top, and again, with the microfiber cloth, you can feel that stuff as it's cooling, and I'm drying. Now, if I've got both cloths in my hand at the one time, this is making everything a lot quicker and easier, isn't it? If I had the cloth over there, and I'm wiping, then I'm going over here, and then I'm picking it up. It's a lot of extra time, and it's a lot of waste of time, isn't it? So, our client is paying us to be as quick and efficient as possible. Now, let's say that I've cleaned the outside here, and that mark is not going to come off. Okay, you know now, after you've given it a good clean, that mark's not going to come off. So what should you do?
Take a picture of the office and film them.
That's right. Okay. We've also got our books. Okay. And when we go through our books a little bit later, there's a section there in the book which says anything that couldn't be done. And this is what you would be writing inside of the book there.
Okay.
Okay. What we do with that information, once we've got that from you, we put that into the invoice and give that invoice to the client.
Okay.
Does that make sense? Okay. If you haven't let me know that you couldn't get that off, and the property manager walks in and she goes, oh, that's still dirty.
Yeah.
I have to send you back to clean that when you couldn't clean it the first time.
Yes.
Yep, so we're all 100% clear on that?
Yep.
Good. Okay, let's have a look over here. Now, what's the best thing that we're going to be able to clean that stove top with? So, it's not really overly dirty, is it?
Yeah.
No? Now, let's say that we had a stove top that was really greasy and yucky. Okay? How are we going to get that clean quickly and effectively?
With
A steel wool?
With the old spray.
Okay? Spray.
Dishwashing liquid.
Yep. Yep.
Steel wool?
Still wool?
Warm
Okay.
water.
Okay. I'm going to just explain something. Can you grab me the oven spray and the filter clean, please? Okay.
The one time? The what?
Yeah, and the filter clean, the white powder in the bag. Okay, so this is a typical oven cleaner, yeah?
Okay.
This one, Darby? Yes, please? Perfect. Okay. So, this oven cleaner here, up the top of it says poison. Yeah, okay. Now, did you know that on the back of here it says, read the safety directions before use. Wear thick, long, rubber gloves and eye protection at all times, and do not allow product to contact skin, hair or clothes. Okay. How many of you have used this product before, or a similar like product, and haven't used gloves?